Hi guys, and welcome to this Model Engineers workshop. Today in the workshop, we're going to make a backing plate for a lathe chuck to go on the rotary table. Come on. Hi guys, I'm the chef. Today, as I just said, we're going to make a backing plate for a lathe chuck to go on the rotary table. I've got the chuck and a couple of bits on the workbench, so come on, I'll talk you through it. Righto guys, so here we are on the workbench. This is a 5-inch 3-jaw, self-centering 3-jaw chuck. You can see 5 inches, 125 mil. That's what that means. From the company Vivor. This was the price was right, so I bought it. It's cut straight out of the box just now. Came with the chuck, of course. These jaws, the external jaws. Is that right? Yeah, I think it is. Already fitted. Came with the 3 bolts that go in the back. I've just screwed those in to make sure they're right. Also came with its own chuck key, of course. Came with a set of reverse jaws, and it all moves. Put the chuck key in it on the edge of the bench, and it all moves nice and freely. There's a lot of oil in there, I'm sure, but I'm going to leave that in there. No point cleaning that out. So what are we going to do? Right, this has got to go onto a backing plate, which then goes onto the rotary table for when we're on the mill over that way. So we can hold things in either these jaws or from the outside holding in, especially for the cylinder covers. They're a circular, big circular disc of cast iron. We'll be able to hold on to those. And we've got all the bolt holes to drill around that front and rear cylinder covers. And some of them have funny angles and all this. So that's where the rotary table is going to come in. Now, of course, between this and the rotary table, we have a big chunk of steel, which is over that way, behind me at the minute, which I've already mounted in the 3-jaw. And we've got to bore a big hole in the middle, and we then got to turn a register. Now you can see just there. I've got to turn a register so that that surface, this surface, not this one, this surface needs to be free. But this surface then goes flat down onto the steel plate that I've got. It's actually an old wheel blank. When I was making the tender, I managed to screw one up. So it's been in the scrap box for a few years, and now I've got a use for it. And so we're going to turn that register. We're then going to mount that onto the rotary table centrally. Now, how are we going to do that? Well, that's where this comes in. This is an MT3 arbor. Does it say on there? It does. Yeah, MT3. Can you see that? Yes, there we go. So this is a Morse taper 3. This is 32 mil diameter at the end, and it's 32 millimeter thick. Now, this is actually meant as being machinable. So if you're making some kind of specialist tooling, you can always turn a different taper on that. You could turn it down. You could drill bolt holes into it to bolt something onto it, and then that just goes into your tailstock, or some lathes have MT3 as the taper in the spindle bore. My lathe has an MT5, but I have an MT5 to MT3 adapter, so I could always use this in the lathe if I wanted to. We're not actually going to do anything to this. As I said, we're going to, in the old wheel blank that I've got, we are going to bore a 32 millimeter hole. It's a nice, gentle fit on this. So this goes into the center. I'll just use this as a demo. Goes into the center of the rotary table. We'll then drop the backing plate with the chuck on it onto that, and then we can bolt down onto the rotary table with 4 little clamps. That guarantees that then this, through the plate to the chuck, is then concentric with the rotary table. Of course, before we put that plate on, this is nicely centered in the middle of the rotary table. We will then be able to center this left to right, back and front on the mill, so we know exactly where the center of that is. Yeah, once we've got that, we set everything to zeros, the DRO, the dials, all those things, and then the plate goes on with the chuck already on it. We then bolt it down, and we're ready to go. We can then use the DRO, the dials, to actually move the whole thing this way, and then we just go drill, turn, drill, turn, drill, turn, drill, turn, drill, turn. All we have to do then is watch on the graduations on the rotary table itself, so we get the degrees right as we go around. And this is going to be an interesting exercise. It's been a while since I've made a lathe backplate. I had to make two. When I got my lathe, I also bought a self-centering 4-jaw chuck. They're a bit rare on the market, but they are out there. So I had to make a same again, hole through the middle, and then a register for a chuck. And on the back of that, I had to make the taper and the pins that go for it, because my lathe has a D1-4 spindle nose. So there's 3 pins on a D1-4. Great. There's 3 pins that need to accurately locate into the cylinder bore, and as you tighten the bolts up and everything, it all just sucks up onto that taper. The other one was for a little collet chuck. I think you've seen that used a few times on the lathe. It's always worth having that ER32 collet chuck, and I made a backing plate for that as well. Right, that's enough jibber jabber from me. I'll get this back in its box, nice and safe and clean and tidy. There we go. Put that out of the way. Don't need this for a while. We've got a honking great hole to turn, 32mm in the blank over there, and then we'll start turning off a lot of steel to get this down to the 95 that it needs to be. The disc at the moment I'm using is 150, so it's going to leave us like 12.5mm sticking out each side, which will be just enough to put a bolt through, and this little end hold it all down to the rotary table. Righto, that's it. Enough chitter chatter, whatever from me. Off to the lathe. Here goes. See you in a bit. Righto guys, here we are on the lathe. This is the old wheel blank I'm talking about. As you can see in the hole in there. I remember doing that. Of course, when you're boring inside out, you have to turn the dial the other way. So when you're coming back, you need to move the tool that way. Guess what? I moved it this way, just wound it straight back, buggered up that final cut, didn't I? So anyway, this has been in the scrap bin for many years now. Ignore the blue, that's nothing to do with this operation now. So we're going to bore this hole out again to 32mm to fit that MT3 adapter. And then we're going to turn about 3, maybe 3.5mm off this face till we get a register of 95 here. Once we get a nice snug fit on that, then yeah, we'll be doing really well. Yep, so let's get the machine going. Let's make sure we've turned on. Yep, click, there we go. Machine's all set as far as I can tell. We've got the feed on a B5, which is nice and slow and steady. Can't remember what grade steel this is. I think it's something like K1025. I don't even know if that's a valid grade anymore. As usual, I don't know. Can you see that? Maybe you can. Just here, boring tool, boring bar, just literally long enough to go through that hole and out the other side. Yep, so you don't want any more stick out than you really need to, because otherwise it's just going to start vibrating and chattering and making a lot of noise, although it'll probably make a lot of noise anyway. Right, as you can see, as I always do, I always spin the chuck by hand first. That's it, we're into gear now. Yep, there we go. And just to make sure it's not going to hit anything, make sure everything's clear. There we go. Yep, good. Right, let's get a couple of cuts done, and yeah, after that, I'll do a couple and bring you back when I get up to, almost up to size. All right, guys, here goes. Into the hole. Get a touch off. There we go. Line that out. Just put on a light cut first, just to clear out that hole first. Right. Let's get this onto the power feed and we'll see how we go. Cutting nicely so far. Won't be far coming through now. There we go. Stop the feed. Wind the table in the right direction this time. Yep, there we go. Wind back out. That's done a lovely job. Yeah, nice finish in the inside of that. Okay, right. You get the idea, guys. I'm going to stop it there. That's what, a three and a bit minute clip. So I'll stop you there and I'll bring you back when I get closer to 32. All right, guys, see you in a bit. Righto, guys, so I've taken a good few cuts already. I just have to measure up. I know we're getting close. Have a quick look. 31.15, so we're very close. This, of course, is the adapter we're going to be using. This is 32, as I said. I don't know, can you see that? Yeah, probably can. So 32 is target. This just needs to be a nice, easy, sliding fit in that hole. Not going yet. We've got a nice chamfer on here, so the that chamfered part is going in, but not the rest of the body. So we'll start taking some lighter cuts, again using the power feed as always, and got a lovely finish in there. Let's get the tool moved up, and we'll just take it a little bit at a time. Power on the lathe, everything free, and we'll just get a little bit of feed on. There we go, and we'll take some light cuts. Here goes. That theoretically should have been, let's put the dials back, about 0.2 of a millimeter. Let's clean out the hole with the finger. Quick measure up again, just to see how we're going. That's about right, I think. Let's have a look. 0.35. Yep, 0.35. So we're doing well. Right. Let me get a little bit closer, guys, and I'll bring you back. Righto, guys. So got this pretty much to 31.9. Just going to have to just take this very slowly now. Literally going to be taking dust off, trial fit dust, and just keep going till we get that nice sliding fit. So here goes. Right, let's clean out that hole. Give it a good old dusting as well. Back a little bit more. Now, measured this, of course, on the hour that is 32 exactly. Best as I can measure it anyway, so not quite. Oh, it wants to go. Yep, all right, let's do one more division. Let's see how we go. We want this to be as accurate as possible, of course, so that when we set up the rotary table, we're going to be accurately centered onto the rotary table itself. Okay, one more cut, then try again. Again, get everything nice and clean before we try. Oh, man, That's close. Right, this is what it's all about until we get it to where we want it to be. Here we go, let's have a go. Oh, it's still not there. Although we are so close. Right. Just don't want that to roll onto the floor. There we go. Here we go. I don't think that you guys will be able to hear that in the background, but it's actually raining here in South Australia at the moment. It's a bit of a rare occurrence. Oh, look at that. There we go. Look at that, guys. Beautiful. That's what we wanted. That is just what we wanted. That is absolutely ace. Right, we can move on to the next job. I'll turn the cameras off, reset, and we'll get the register cut. Here goes. Back in a tick. Right, guys, so tool change. Back to this one. I've touched off against this face just to give me some reference point, if nothing else. Just make sure I've got that right. Looks about right. So it should be there. Looks good. So I'm just going to touch off on the outside edge of this now. Get once the lathe's running, take a clean up cut, and then we've got to go to start building the register, cutting the register. So we need it to be 95 diameter to fit the inside of the chuck, and a maximum of 4. So I'm probably 4 deep. So there's quite a bit of material to come off. Probably going to get it to about 3.5, just so there's no interference with the back end of the chuck itself. So let's get this touched off, and we'll get a cut put on, and get a facing cut, get it cleaned up, get our blue line off, all that blue muck off anyway, and then we'll start making the register. Here goes. There's touch off. Yep. Right. Let's put on a little bit of a light feed, nothing too serious, and engage the power feed all the way across. Nice and slow and steady, get a good finish. Well, it's not liking that. Okay, well, it wasn't liking that, was it? Right, let's just drop the speed down a little bit and see what we're at. Let's go down to a little bit slower. Let's go down to a C3. There we go. That surface feet must have been a bit high. Here goes. Let's try again. Engage the power feed. See how we go. Still not liking it. No, I think I've just... Get the feeling I think I've just destroyed that tip. Let's have a look, see, shall we? Can we see? Yeah, there's a little bit of damage on that corner maybe. All right, okay, I'll spin that round and bring you back. Let's try again. Righto guys, as you can see I've moved on a little bit. Did a bit of experimentation, burnt out another couple of corners on an insert. I've changed to an insert of a different grade. These are M2 grade. I think they're really meant for stainless, but it might be just something to do with the steel. I know this isn't stainless. Anyway, you can see I've just done a little bit of a cut there. It's still coming off very stringy, which is not the best thing. So I'll have my long handled. Where can you see? Yeah, I've got my long handled pliers to hand, because of course you don't want to get your fingers caught up in that, and it seems to be cutting better. So I'm just going to take a finishing cut across here now to let you see, and then we'll start cutting for the register. All right, here goes. Let's see how it goes. Certainly cutting nicely. Let's just get those string of chips out of the way. Not coming off quite so blue now. Oops, sorry guys, that was me. Looks like we're getting a good surface finish. You can see the reflection of the insert just over here. And get that out of the way. There we go. Oh, the chips are starting to break up a bit now. You can see not quite so long, not so stringy. There we go. Right. Wind that clear. Turn it off. Come back out. How's the finish on that? Oh, that's lovely. Goodness me. Yeah, I think I'm running a bit fast on the outside, so I'm going to slow it down, because you could see here towards the middle it was getting nice. The chip breaker was working properly. So I'm going to slow it down a bit more. And let's have a think. What's the next one down? Would be B2. Right, let's engage the next speed down, which is going to be about that, I think. So what I'm going to do now is I'm going to create. So we need to come down from 150 to 95. So 55, that's what, 27.5 each side. I'm going to come in about 25, get it down to almost depth, so like 3.5, 3.5, somewhere between there. And then we'll start making sure that that register fits, and then we'll finish off and get a nice sharp corner as well. So I'll do the first cut on that. 25 mil is going to be, now let's call that 10 turns on the cross slide, so I can count those for the first one, and then we can go to power feed and just match up every time after that. So let's have a think. I think we were there at 20. Yep, looks about right. I'll just take it nice and steady and see how we go. Here goes. Alright, that should be touching off. Almost. There we are, there's touch off. One turn. Two turns. Three turns. Four turns. Five turns. Six turns. Seven turns. Eight turns. Nine turns. 10 turns. And back at that. Let's just do a quick measure just to make sure things are looking right. So let's have a look. 20, about 26, 25 and a half, 26, which is where I want to be. So I'm now going to take this surface down 3.5, and then we can work on getting the register fit. Right, I'll bring you back when I get the 3.5 off, and we'll start work on the register. You've seen what I'm doing, so there's no point repeating that. All right, guys, see you back in a bit. Righto, guys, so that's just about 3 mil. I'm just going to take a little bit more off, get to about 3.2, and then we can start sizing up on the register. So here goes. This insert seems to be holding up quite well. Just strip out the feed, the power feed, go to my marker, there we go. Just wind that clear slightly, wind back out. Let's reset that dial, there we go. Now we have a lovely finish on that, absolutely beautiful. Let's wind that tool clear and see what we're up to. So it should be somewhere around about 100, I think, all being well. There we go, target of course being 95, and I can see we're at 99. Can you guys see that? Yeah, you can. If you got a second or two pause, you'll be able to look at that. We are on 99 exactly. Right, okay. Good. Whew. So what we're going to do now is bring the tool back out. Bring it in this way, back out this way, tool in that way. We know we're at 99, we've got 4 to take off. So we can then just make sure we reset this one there to 0, which is there. And we can put on a feed like that. Now it's just a case of going bite this way. And then once we get this down to 95, we'll do one last cut and clean up any rough bits left over. All right, let's get this done. Here goes. Just got to make sure I take that quill lock off. Get in there, come on. Yeah, that quill lock is off. Good. Right. Chuck's free. Here we go. Let's take another bite off and then we'll remeasure just to see how we're going. should get us down to 97.5 maybe. God, I hate it when it does this. Those little birds' nests. Right, so let's see where we're at now. We were at 99. We should be at about 97.5, 97.6 maybe. Just take our time. Again, same as the ball. I've got a D-burr. There's a nasty burr on the inside of that now from the turning. We've got to get this to a nice, easy fit. We are on 95, 6, 7, literally 97.5. Right. Next cut. Now, that should be what? Somewhere near 96 now, so we're getting very close. Yep, 96. So I'll do one more big bite, and then we'll probably have a small bite to go. Right, let's have another measure. This should bring us down to, I don't know, 95.4, 95.2. Somewhere around there. Let's have a look. 95.25335. About 92.35. Right, let me just grab the chuck, guys, and we can have a bit of a trial fit. And it won't fit yet, but let's no harm in trying it. And I'll bring you back in a tip once I grab the chuck. Hang on. Righto, guys, so I've got the chuck. There we go. You can see where the register's got to go. Let's have a try. Oh, and that is close. Very, very close. Right, so put that there for now. Yeah, let's just go same as before. Actually, I'll get that out of the way. We're just going to take little bites until it fits. I'm just setting the dials here, guys. All right, so nice and free. Let's just literally take off some dust until that fits. Here goes. Okay, let's try that. We are so close, it is just not worth taking the gamble. We need a nice drop on fit. Yeah, we are so close. Put the chuck out of the way. Right, this back in there. That's where we were at, I believe. So let's just put on another light cut. Here goes. Try for fit. Whoa. Every time just a little bit closer. Going down in tiny, tiny little bits now. Yeah. Let's just get that to the right marker. Should be about there. Yep. Yep, all good. Oh, look at that. We're on. Yes, indeed. Oh, look at that. That's even going to hold itself. Whew. Right, guys. Good. That's a step forward. Yes, indeed. Right. I've just got to deburr this a little bit and take this out of the chuck now and get it on the workbench, and we'll talk through the next bits that's got to happen. All right, guys. See you in a bit. Righto, guys. So there we go. This side is now ready for the next stage. So we've bored that so it fits the hole. You're going to go in for me? That is a lovely fit. And it even goes popped. I don't know. Did you hear that? I know I can hear it. And that's just resting on a piece of paper here. So one more time, I'll go quiet. Pop. Lovely, isn't it? Right. Just the fit we needed. Of course, we've now also turned the register. It goes in here. So put that down gently. There we are. No slopping that. That's great. That is literally wonderful. I couldn't have wished for better. Now, of course, when this is on the rotary table, we need to hold it down. So the rotary table has 4 slots in it, I believe. He says as he looks back. Yep, 4 slots. So we're going to have to drill 4 slots for, I believe they're M8 bolts myself. So 2 here, 2 there. The chuck itself has 3, and they were they were provided. They always are actually when you buy the chuck. So 1, 2, 3. Now they are on a circle of. Oh, let me just check the Vevor paperwork. 108 mil. That's 95. That's 150. So somewhere in here. Yep, somewhere just around here. We'll be drilling 1, 2, 3. We'll be then on the once we got those drilled through, we'll flip that over, and we will then counterbore those for the bolts to come through and hold the chuck on. Once we get 7 holes done, flip it over, counterbore, and bolt it all together, and it can go onto the rotary table. Right, this now has to. I now have to mount this on the mill. I'm going to have to take the vise off, mount this up on some blocks so that it's clear of the table, and then we can use the DRO setting against this dimension, because we know that this is concentric with that. We don't know how concentric this is with either of those two. We don't really care at the moment. It doesn't matter. But we know these two are concentric because they were turned in the same setting. So we'll do the center and the center on that. Gives us the center of the hole, and then we can use the DRO at the right spacings to do all of these holes. And as I say, they're all M8, which makes life easy. It's all one drill. All right, guys, let me get set up on the mill, and I'll bring you back when you're ready to start drilling some holes. See you in a bit, guys. Righto, guys, so here we are. I've just taken the vise off because there wasn't enough room at the end of the table here. Got this on a couple of parallels, a couple of bits of stock, not parallels, a couple of bits of even stock, scrap stock. Yeah, there we go. They're nice under there. They are scrap. If I do hit one, it doesn't really matter. So we're going to have to drill 3 holes in the outer rim of this. So 1 here, 1 here, 1 here for the hole down to the rotary table. And then we're going to go to a different PCD. So another circular dimension, and drill the 3 holes, 1, 2, 3 here. That'll hold the 5-inch chuck down, the 125mm chuck. So what are we going to do? Somewhere around here. I thought I had everything ready, but not. Yep, here we are. So center drill, 5mm drill, which is this one, of course. And I'm going to go through with the 8mm, which I'll probably drill a little bit large. Doesn't matter. It's going to be this clearance for a bolt anyway. And after that, yeah, these ones are going to be really close to the edge. There's not going to be a lot of material left. Doesn't matter. These are only the hold downs to the rotary table. So it's not a great problem, even if at one point we have to just a couple of saw cuts and turn them into slots. It doesn't matter. The important thing is that the head of the 8mm bolt will be not interfering with the outer dimension of the chuck, the 3-jaw chuck we're going to put on here. Right, so I'll get this going. I'll do the first one, might zip it through a bit, and then when I get these 3 done, I'll bring it back and we'll do the same again. Actually, I might just come back when I've got all 6 done, it'll be easier. All right, let's do this first one and I'll make a decision from there. Here goes. Going to get noisy as always. Hang on, guys. Righto, guys, that's number 1. 3 to do on this circle, 3 more to do on an inner circle, which I'll stagger so they don't all line up in one spot. And I'll get those done and I'll bring you back and we'll do the next operation. All right, guys, see you in a bit. Righto, guys, so there we go. 1, 2, 3, 4, 5, number 6 being underneath this clamp here. I've taken it off the parallels or the stock just to keep it off the mill table. And of course, now I've lost the coordinates on the DRO for drilling the hole. So what are we going to do? Well, I've already lined this one up. As you can see, that 8mm drill will go straight back easy through its 8mm hole. What we're going to do is I'm going to use the carbide again. Can you see that? Yeah, you can. This is a 1/2 inch carbide, which is more than big enough, I think. I better just measure that, don't I? I don't think I've measured that one just yet. So the plan is just to run that down to a depth of about 8.5, as I just measure this up. 12 point, yeah, that'll just be about right. So that one of these bolts will be able to have its head counterbored into the base plate. Of course, we can't have the heads sticking up because, of course, this surface goes flat down on the table of the rotary table. So we've got that one lined up. And so let's get this whole thing changed out. Drill, chuck and everything. Drill, chuck and everything. Yep, and we'll get the carbide cutter going in. And we'll loose it coming up. There we go. Let's see if we can get that out of there. No, of course we can. Right. Let me just screw that back in there just to hold it. Knock the drill out. There we go. Yep. Now I'll take the chuck out. There we go. Swap it over for the carbide. And I can bring the table up. Then I can bring the table up so I don't have so far to travel. And I've lost the spinner. Where is it? There it is. Just tighten this up. There we go. Bring the table up, so I don't need to go so far down with the quill. As I say, I want to go down about 8.5, which I'll do with the slow feed on the quill rather than using the drill handle. Now I can set that. What did I say? I need about 8.5, so let's go to 8.5 on that graduation there. Right, lock in the hand feed. There we go. Yeah, nice and slow. I will just grab my bottle of wherever that's gone. I'm looking for my bottle of cutting fluid at the moment, guys. Oh, where's that gone? Honking Great spray bottle. Can I see it just yet? No. Is it down there? Don't know about anybody else, but I think this workshop has gremlins for sure. They've buggered off with me spray bottle of cutting fluid. This is quite tough steel. The drills were... Oh, there it is. Right, we're back in business. Oh, there's not a lot in there, but that'll be enough for 3 counterboards. Right, so running the mill about the same sort of speed, and I need to go down 8.5 mil. Here goes. It's about 4.5. Let's just clear that out. All that crap out of the way. Right, off we go. Cut the next 4.5. Two to go. 1. That will do it. Shut that down so you can hear me again. That'd be a nice cut, that's for sure. Right, let's drop the table out of the way. Glad I'd never make money at this. I'm telling you, just wouldn't be fast enough. Now, let's have a look, see. Look at that. Could use to go a little deep, little shallower, a little deeper. Sorry. That's not quite underneath the surface, and this is why you check, isn't it? Right, let's bring that back up. I'll do this. Right. Just go steady so I can hear when or feel rather, when I hit the bottom. Ah, there we are. Let's just put another meter on it to be sure. Maybe a little bit more. There we go. Right. So that's probably about 10 mil deep, 9.5. I'll kill that noise, you can hear me talking. Right, let's just have a check. Oh yeah, there we are. So we're well below the surface now. Maybe there's even a bit of swarf in there, I don't know. All right. Well, any difference to the final result. Right, I'll get this one and this one done, and I'll bring you back and we can have a trial fit. It's going to be fun, isn't it? All right, see you in a bit, guys. Righto, guys, there we go. Chucking plate. You can see the counter bores here. You can probably see, which one was it? This one here. That's not very concentric, and so I tried the bolt in it, and it was really tight up against that edge. So what did I do? I quickly chucked them in the lathe. Literally took the black oxide off them, and now they are. He says, hopefully, you can see that's really close. There's room on the side. There's not much on that. So that one, yeah, easy peasy. But they're all the same, so it doesn't matter. Eventually, don't need to remember. It's unlikely this chuck's ever going to come off this backing plate anyway. So right, let's do a test fit, shall we? So we've already got the register, which is, look at that. Nice. Right, let's line up. Oh, there we go. You could feel it almost. Right, any bolt. Screw that one into there. That one into there. This one into here. Get them all down a bit first. There we are. That's the one that wasn't very concentric. Or was it that one? Oh, maybe I had two, but okay. I skimmed the bolt. Just took literally not even half a mil off, like 0.3 of a mil off the diameter. Oh, they're starting to tighten up nicely, as you can probably see. Oops, there we go. All nice below the surface. Right, let's turn that over and see what it looks like. Oh, that's wonderful. Look at that. Holes are nice and clear. I don't think a bolt head will interfere with this. The key, if it does, I've got 3 bolt holes, and of course they all line up perfectly, don't they? If they do interfere with the chuck key, the M8 bolts, when I get them, I'll go out tomorrow and get some. We can easily just skin the heads down a little bit. Again, this is only going to hold it down to the rotary table itself. Right, so what's the next thing? Right, well, we're going to get the rotary table out. That weighs 30 kilos, so that's going to be fun. Get this on the top. Get these bolts in with the nuts, 2 nuts. There's the 2 nuts, 3 of them. So they'll go into the rotary table itself. 1, 2, 3. M8 bolt going down through, little head on the top. If it needs a washer, I'll find some washers, or I'll make some washers, doesn't matter. Could probably use like rectangular washers, just to spread the load maybe. But again, it's just a hold down. It's not actually going to take any great load. This will take more of the loading than that, and it'll just even itself out as it transverses through to the rotary table. Then, of course, we have to make sure, because, of course, when we get the rotary table, this goes down in the middle. This plate goes over the top. And if I turn this over, I should try this first, shouldn't I? Here we go. Of course, we know that hole fits, but how far down do we actually go? Oh, it's still a good fit. Look at that. Right, so we might just have to, this is soft, it's not hardened. It's meant specifically for this kind of thing. We can keep the center in there, and we can just turn that down so it goes through the bore of the chuck itself. And that will allow this to stay in place. Because that register there, that 32, does not fit through the bore. The bore of this chuck is 29, 28, something like that. And so, actually, if I get that, you can see that, yeah, no, it might even be 30. I wonder, let's have a look. I'm just having a look at the Vivo specifications. It's 30. Look at that. So we wouldn't have much to take off the outside of that, but still just leaving enough, even if it was 3 mil at the bottom here, to form the register for the backing plate. Right, guys, let me get this reset. See if I can give myself a hernia, moving a 30 kilo rotary table. It's only a small one, it's only a 8-inch, I think, onto here. And we'll try fitting this up properly. All right, guys, give me a minute. I'll be back soon. Hang on. Righto, guys, there we go. 8-inch rotary table. Got it into gear at the moment, so of course you can crank it. You can see down here you've got divisions, degrees and minutes, so that you can actually go down to what, 10 minutes. which is what, 1/6 of a degree. So turning 360 into, God, nearly 2,000 parts, isn't it? So yeah, 8-inch. As we've already talked, we have MT3 arbor, which of course just drops in there. I've taken the chuck off the backing plate at the moment because I know that this is too tall. Now I don't want to drop anything off the height. I just want to make sure that that goes into the hole in the back, the bore of the chuck at the moment. So I'm just going to put this on here. Oh, it's still a good fit. Such a good fit. It jammed on me. Let's try that again, shall we? Nope. Man, that's not jammed on there permanently. There we go. Right. Let's try that again. Right. Are we gonna go or what? Yep, there we go. That's more like it. Doesn't matter where the holes fit at the moment. They do actually all line up. I've never checked that before. So we need to turn this little bit off. Not off, but in diameter. We need to reduce it. We know the bore's 30. We know that we want a bit of clearance, so 29, 29 and a half, something like that. Right, that's, so we just need a mark on there. Hopefully we've got a mark now. I think I've got it more on the plate than on the thing itself. Let's lift that off. Yeah, there we go. Sorry for the arm. Right. That's a good fit. So there we go. We need to keep turning until that disappears. And so this bit here, from the thumbnail to the top, we need to get down to, as I say, less than 30, so it'll fit in the bore of the chuck. Right. Give me a few minutes to reset, and I'll bring you back. We'll get this turned down. Project is getting very close to finished. Once this is done, we can bolt it all together and see how it goes. All right. Give me a second, guys. Here we go. Right, guys. So there we go. I've got this held in the 3-jaw. There's just enough of that head left that we're going to be, we have enough to hold on to. Otherwise, we'd have to think about using an MT5 to MT3 adapter to actually put this straight into the spindle. Concentricity at this moment in time is not that important. This to that, to the rotary table, to the backing plate is. So what we're going to do is we're going to get 2 mil, not even, yeah, this is 32, we've got to get to less than 30, so 2 and a bit mil taken off this. Let's hope this isn't hardened. They told me it was sold as a machinable arbor. So let's see how we go. All right, here goes, guys. Make sure everything's free as normal. Here we go. Seems to cut quite nicely on that bit anyway. Here goes. Oh, that's machining nicely. I'm just watching the black line go round, around, around. Somewhere about there. Let's wind that there. Let's do that again. Actually, I'll just check that. That's where my black line was. I don't know. Can you see that? Yeah, probably. There was half a black line there, so I'm going to take just a little bit more off. I am just going to slow this feed down. That was a little bit fast, I thought. Let's get down to a really nice slow feed, give us a good finish. Not that it's that important, it's just up the middle of a lathe chuck. There we go. Yep, that should see it. All right. Whoops, a little bit more controllable. Right. Where's my black line there? Okay, so we're going to probably go about 1/2 mil more than that. Here goes. Just nice light cuts. Catch it there. I think I've just destroyed. Oh no, I thought I'd destroyed that tip. Just give me a second, let's have a look, see. Yeah, just destroyed that tip. Right guys, give me a second. I'll change the tip, I'll get this down to size and I'll bring it back. Righto guys, there we go. Down to 29.6, so that should be not a rattle fit, but a loose fit through the bore of the chuck, so it's nothing precise. It doesn't need to be, so I'm not going to bother making it. I'm just going to now take the tool and go in a little bit down to this surface that we've just created, just to give us a nice square corner so it's not going to interfere with anything. And then you need to just chamfer this top edge. So here goes. There we go. That's that bit done. And then it's going to knock the sharp corners off, as always. File, handle. Can't say it enough. Yep, nice and clear. Done. All nicely done now. Yep, well, might be a bit there. Hang on, let's have another go. Let's have a go at the back end here. Right, here goes. That's better. Yes, 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 that's better. Right, this project is rapidly getting to a close. Right, let's do one more quick chit chat back at the bench. Can you see that now? Oops, get it lined up with one of the cameras anyway. There we go. No sharp edges on there, no sharp edge on there. In fact, you can see there's a nice little chamfer just on that. Look at that. Right, back over to the bench, guys, and let's get this thing put together and make sure everything fits. Here goes. Righto guys, back at the workbench. Here we go. This is what we just turned, of course. Again, no burrs. So let's just do a dry run, no bolts, and then we'll see how we go. So that goes in there. I'm using this collar now for registration against the backing plate. I'm just making sure that's nice and clean. And just run your hands over it. You'll soon feel if there's anything there. That, of course, is the loose fit. Then here we hit the collar. Oh, look at that. That's just down below. I can't zoom in. Yes, there we go. You can just bring you up a bit as well. Yeah, you can see that is just below the surface. That's great. There we go. Get the chuck now. Of course, we're not registering on this. We're registering on this. So again, nice and clean, wipe it down. That's a nice fit on that. Gently. And that is a lovely fit on there. Look at that. It's almost the magic roundabout, isn't it? Look at that. Right, so now let's just get this bolted together and you'll see the finished result. So, whip that off. Whip that off. Just take that out for now. So, chuck, backing plate. Make sure, again, every time, nothing there. The backing plate. Sorry guys, there go the holes. In go the bolts, the shiny ones, because I had to turn the heads off a little bit. Nothing critical for this job, of course, that the bolt heads aren't quite the same size as they were when we started. Sorry, my arm's getting in the way, but Get these all kind of tightened down and then round one more time. Yeah, there we go. Again, don't need to crank down hard on these. All they're doing is holding the two plates together. They're not doing anything structural. That'll do us nicely. Right, whip that out of the way. Put the mandrel in. This whole thing then drops over the top. Carefully, of course. Don't get your fingers stuck or anything like that. There we go. Can you see what I'm doing? Yes, you can. T-bolt, T-nut rather, goes in. Just ease that into there. There we go. That's tightening up. Nice. Let's get number 2 in over the back. There we are. These, of course, are only forming the drive to make it go round. And 2, 3. And they don't even interfere with that. Look at that, isn't that nice? Lovely. Phew. Right, there we go, guys. One backing plate for a lathe chuck on the rotary table. This means we have that ability to either do it very coarsely with the dial around here. There's a pointer underneath here. I think you can just about see that. Or we can actually do degrees and minutes. Now we can loosen that. We can turn that out of gear. And that whole thing just spins as we want it to. Re-engage the drive, lock it down. Back we go. Righto guys, it's time to bring this video to close. Just give me a second, I'll set up and we'll get it done. One more project down. Nice. See you in a bit. Righto guys, there we go. Another video finished for today. Okay, useful project. Gonna bring in the rotary table for use for later on. More than likely for things like cylinder covers where you have to drill lots of holes in a circle. I know I could use the PCD function on the DRO. And for what they are, you could even mark them off with a child's protractor, I suppose. It wouldn't make that much difference because you can still use the actual cylinder cover as a template. You can just hold it down, transfer the holes through, and then drill and tap them from there. So they would be perfectly fine no matter which way you go. But hey, I've got a rotary table. I've never used one. I'd like to give it a go. Righto guys, that's giving it away a little bit because in the next video we're going to start on the rear cylinder covers. No, take that back. We're going to start on the front cylinder covers. They're a slightly easier design than the rear because of course the rear has a hole through it for the piston rod and a fixing point, mounting point for the slide bar. Righto guys, I'll bring this video to a close as I always do. You can find it in your heart and soul. Give me a like, a subscribe. If you've got this far, it's a bit of a long video probably, I know. It's worth a like. Give me a like. That will put this video in front of other people that are like-minded, the same as you and I. And if you've got it in you, subscribe. It's up to you. The more subscribers, the merrier. Just bringing this Australian design to the rest of the world. All right, guys. This is the chef signing out and saying, see you later.